This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at antiderivatives and indefinite integration. Oops. Okay. Now, if we have our function, let's say it's x squared minus 3x plus 2. If we take the derivative of that, that gives us 2x minus 3. And 2 at the end here just drops away. Antiderivatives, this is a derivative right here. Antiderivative is going in reverse direction. So we're starting off with the 2x minus 3, and we want to end up with x squared minus 3x plus 2. Now, we can rebuild part of it. From the 2x we can get x squared, and from the negative 3 you can get negative 3x. But unfortunately the 2 is completely gone. When we took the derivative of it, it went to 0. So going backwards we won't be able to get it. We're going to see how we're going to handle that. We're going to actually put a plus c on there, where the c represents a constant. Now our first problem here says verify the statement by showing that the derivative of the right side equals the integrand of the left side. So we got 2x to the third minus 1 over x squared dx is equal to 1/2 x to the fourth plus 1 over x plus c, which is our constant. And it says verify the statement by showing the derivative of the right side. So we want to take the derivative of the right side and show that that equals the left side. Now this is the integration symbol, and then this dx tells it with respect to what. So we take an integral with respect to x. Well, let's take derivative of the right side. So derivative of 1/2 x to the fourth plus 1 over x plus c becomes derivative of 1/2 x to the fourth. And I'm going to rewrite the 1 over x as x to the negative 1 power plus c. Because it's easiest if we have all as either a constant or x to a power. And remember, this is x to the first, so if I take it up on top, it becomes x to the negative 1. You move anything opposite of where it's at in a fraction, the sign of the exponent changes. Okay, so for our derivative, take our power, put it out in front, and lower it by 1. So we got 1/2 times 4 x to the third. Take our power, put it out in front, lower it by 1. Negative 1 minus 1 is negative 2. And derivative of a constant, that goes to 0, so that disappears. Well, 1/2 times 4 is 2, so we got 2x to the third. And I'm going to take this x to negative 2 back downstairs. We got minus 1 over x squared. And see, that's equal to the left side, so that verifies that. Now we start off with very few properties on this. Formulas. We'll build upon this. Now our first one, the integral of x to a power, so x to the n, dx. Well, we're going to add 1 to our power, divide by our new power. So that's going to be x to the n plus 1 divided by n plus 1, and then plus c. If we just have a constant, and I'll put k there to represent any number, then you put an x on it. So this would be kx plus c. Like I say, we'll add on to that, but for now that'll get us started with this. And let me clear out some of these papers. There we go. Okay. Let's look at our next problem. number 2. We got dy dx equals 5x to negative 2. And it says find a general solution of the differential equation and check the result by differentiation. Differential equations, yeah, we got the derivative here. So we're saying the derivative is equal to this. And when they say find a general solution of it, we want to go backwards. We want to find y. Well, to go backwards, remember integration, antiderivative is going backwards. So to get y, we're going to take the integral of dy dx, which will be the integral of 5x to the negative 2 dx. Now when you have a number inside with your x to a power, you can freely take that number in and out of the integration symbol. So we can take that 5 and put it out in front. Now remember what our property was up there. If we have x to a power, we're going to add 1 to our power, divide by our new power. So 5 carries down, add 1 to our power, so that's negative 2 plus 1, and divide by our new power, so that's negative 2 plus 1. And then we always have to put our plus c on. So then we got negative 2 plus 1 is negative 1 plus c. And I'm going to take the x to negative 1 downstairs, so that's negative 1 x to the positive 1 plus c. Again, you can take anything opposite of where it's at in a fraction and the sign of the exponent changes. So the x to negative 1 becomes x to positive 1. Now this negative 1 here, I'm going to go ahead and put the negative up on top, and I'll put the 5 up there too. So we got y is equal to negative 5 over x plus c. And that's our answer. So again, we can use integration to go backwards and find our original function. Let's take a look at this one. We got 1 over 3x to the 4th dx. Well, on this one, I could split that into two separate fractions. That'd be 1/3 times 1 over x to the 4th dx. Just going the other direction, if I merge these into a single fraction, multiply top parts together, multiply bottom parts together. Now notice that 1/3 is just a number, it's a constant, so we can take it out in front of our integral symbol. Now you can't do that with x's, you can only do that with numbers. You can freely take them in and out. And this 1 over x to the 4th, I'm going to take that x to the 4th up on top, and it becomes x to the negative 4 dx. And we got it to look like our formula. Again, we were trying to get as x to a power. So our formula says we're going to add 1 to our power. So this becomes negative 4 plus 1, and we'll divide by our new power. So negative 4 plus 1, and then we have to put our plus c on. So we got 1/3. Negative 4 plus 1 is negative 3, so we got x to negative 3 over negative 3 plus c, which gives us x to the negative 3. 3 times negative 3 gives us negative 9 plus c. And I'm going to take that x to negative 3 back downstairs. So we'll have 1 over negative 9 x to the positive 3 plus c. Again, anytime you move anything opposite of where it's at in a fraction, the sign of the exponent changes. The x to negative 3 becomes x to the positive 3. Now, I probably don't have room for the next one. What is this section? Antiderivatives and indefinite integration. So let me save this page. Antiderivatives and indefinite integration. Page 01.pdf. Okay, let's look at our next problem. We got the integral of x squared times x minus 3 dx. Now, this integration is much cleaner than derivatives, in my opinion. There is no quotient rule. There is no product rule. With derivatives, it doesn't matter what it looks like. You just dive right in and start taking the derivative, and you have it. But the same isn't true of integration. It has to match your formula exactly. Now, we've only looked at a couple of them, where you have x to a power and we have a number. So we want to get it in this form. And what we can do here is we can multiply the x squared through. X squared times x is x to the third. X squared times negative 3 is negative 3x squared dx. Now remember when we were taking the derivative and we had separate terms, you would take the derivative of each term separately. Well, the same thing here. If we're taking the integral and you got separate terms, you can take the integral of each one separately. So if I take a look at the x to the third, we'll add 1 to our power, divide by our new power, minus the 3 you can just leave out in front right here, and then we'll add 1 to our power, so 2 plus 1, and divide by our new power. Remember, we always have to put a plus c on. So this is x to the fourth over 4 minus 3 times 2 plus 1 is x to the third over 3 plus c. Now this x to the fourth over 4, usually they'll take that number and put it out in front, so we'll have 1/4 x to the fourth. Here the 3's cancel, so we've got minus x to the third and plus c. And that's our answer. So sometimes you can do basic algebra to get it in the right form. Let's take a look at this one. Got the integral of 5x to the third minus 7x squared plus 3x minus 2 dx. We got 4 separate terms here. Again, I'm just going to take the integral of each one separately. I could actually write them as 4 separate integrals. It doesn't benefit us a whole lot at this point. So the 5 just remains. Add 1 to our power, so 3 plus 1, divide by our new power. Minus 7 remains. Add 1 to our power, so 2 plus 1, and divide by our new power. Plus 3 stays out in front. Now this is x to the first power. So we'll add 1 to our power, so we've got 1 plus 1, and divide by our new power. Now the negative 2, whenever you just have a number, then you put an x on it. And then we always put a plus c at the very end. So we'll have 5 times 3 plus 1 is 4, so we got x to the fourth over 4, minus 7 times 2 plus 1 is 3, so we got x to the 3 over 3, plus 3 times 1 plus 1 is 2, so we got x squared over 2, minus 2x plus c, which gives us 5/4 x to the fourth minus 7/3 x to the third plus 3/2 x squared minus 2x plus c. And that's our answer. Let's take a look at this one. Excuse me. So we've got the integral of the 5th root of x squared minus 2 dx. Now we have 2 formulas right now, 2 properties. Basically, you either have to have x to a power or a number. Well, this is a number, so that's okay. But we can't have a radical. Well, I'm going to rewrite this. I'll rewrite it as x to the 2/5 power minus 2 dx. Remember this number in the slot here, that's called your index. That's what goes in your denominator. And whatever power is inside goes up on top. And if there isn't a power, you put a 1 up there. Well, now this is in the right form. So we'll add 1 to our power. So we've got 2/5 plus 1. We'll divide by our new power. minus the 2 is a number, we just add an x onto it, and then plus c. Two-fifths plus 1, this is a mixed number. 1 times 5 is 5, plus 2 is 7, so we got 7/5. So x is 7/5 over 7/5 minus 2x plus c. Now whenever you have a single fraction down your denominator, you can flip it and multiply it times your top part. So this becomes 5/7 x to the 7/5 minus 2x plus c. And that's our answer. Let's take a look at this one. Got the integral of x squared plus 5x minus 2 over x to the 5th dx. Now there is no quotient rule, no product rule, no chain rule. You have to use some basic algebra to get it in the right form. We want is either x to a power or a number. Well, notice we have a single term down our denominator. Whenever you have a single term or single item down there, might be a single radical, might be a single trig function, then you can split these into separate fractions. So put the x squared over x to the 5th plus 5x over x to the 5th minus 2 over x to the 5th dx. Well, this first fraction simplifies. This becomes 1 over x to the 3rd. Remember, when you have x to a power over x to a power, you subtract your smaller exponent from larger one. 5 minus 2 is 3. And you have x to that power, x to the 3rd power, where your larger exponent was, which was downstairs. Plus 5 over x to the 4th minus 2 over x to the 5th. Well, if you have x to a power down your denominator, you can take it and move it up on top. So this becomes x to the negative 3 plus 5 x to the negative 4 minus 2 x to the negative 5 dx. Anytime you move x to a power opposite where it's at in a fraction, the sign of the exponent changes. And now everything's x to a power. Now you can have numbers in front of the x. That doesn't change anything. So our formula says add 1 to your power, divide by your new power. So we're going to have x to the negative 3 plus 1 over negative 3 plus 1 plus 5, add 1 to our power, negative 4 plus 1, divide by your new power. Minus 2, add 1 to your power, so negative 5 plus 1, and divide by your new power. And then remember, we always put the plus c on at the end. Negative 3 plus 1 gives us negative 2, so we got x to the negative 2 over negative 2 plus 5x, negative 4 plus 1 is negative 3 over negative 3 minus 2, negative 5 plus 1 is negative 4, so x to the negative 4 over negative 4 plus c. Well, we want to take the x to the negative powers back down to the denominator. So this becomes 1 over negative 2x squared plus 5 over negative 3x to the 3rd minus 2 over negative 4x to the positive 4 plus c. Remember, when you move anything opposite where it's at in a fraction, the sign of the exponent changes. So when I take those x to the negative power downstairs, they become x to the positive. Now if I want to, I can put this negative up on top. So this would be negative 1 over 2x squared. This negative I can put out in front. So minus 5 over 3x to the 3rd. Now here we got a negative negative. So that becomes a positive. And 2/4 reduces to 1/2. So this would be 1 over 2x to the 4th plus c. And that's our answer. And let me save this page. Now these next problems, you see we got a cosecant squared here. We got e to a power. We got 1 over cosine squared, which we have to handle a little bit differently. We started getting into the trig. And then, of course, e to the power, too. So let me write those formulas down. Okay, so if we got the integral of sine x dx, sometimes just thinking of these going backwards helps you come up with the integral. But this would be negative cosine x dx. Or, sorry, negative cosine x plus c. Think of it going the other direction. Derivative of cosine is negative sine, and a negative out in front, negative negative becomes a positive sign. The integral of cosine x dx. Well, that's going to equal to sine x plus c. The integral of secant squared x dx is going to equal to tangent x plus c. Think what the derivative of tangent is. Derivative of tangent is secant squared. The integral of secant x tangent x dx is going to equal to secant x plus c. Again, the derivative of secant is secant tangent. So you see how they kind of go backwards? The integral of cosecant squared is going to equal to negative cotangent. The integral of cosecant x cotangent x dx is going to equal to negative cosecant x plus c. And even though it doesn't belong here because those are the trig ones, the integral of e to the x dx is going to equal to e to the x plus c. That one's kind of self-evident. Because remember when we found derivative of e to the x? The derivative of e to the x was e to the x. So the integral of e to the x is e to the x. So these are the next formulas we're going to need. So let's take a look at this. We're finding the integral of theta to the third power minus cosecant squared theta d theta. Now, you can have x's here, you can have theta, you can have any variable actually. It's still the same idea. Remember when we had x to a power, we added 1 to our power divided by our new power? Well, theta to a power is the same way. We'll add 1 to our power, so we got 3 plus 1, and we'll divide by our new power. Minus the integral of cosecant squared is right here. The integral of that is negative cotangent x. So we're going to have negative cotangent theta. And then I'll put my plus c on at the end. Now notice I put that inside of parentheses because this negative just carried down and this negative came from the formula. Well, 3 plus 1 is 4, so that gives us 1/4 theta to the fourth. Negative negative, so plus cotangent theta plus c. And that's our answer. And let's look at this one. We've got the integral of 5x squared minus 4e to the x dx. Well, this one's just x to a power. 5 stays out in front. We'll add 1 to our power, 2 plus 1, divide by our new power. I'll eventually quit putting that plus 1 and just go ahead and add them. 2 plus 1 is 3, of course. Minus 4, and derivative or integral of e to the x is e to the x. And then we put our plus c on. So then this becomes 5 times x to the third over 3 minus 4e to the x plus c, which gives us 5/3 x to the third minus 4e to the x plus c. And that's our answer. Probably shouldn't have labeled these that way. I don't want to mix them up with my actual problem numbers. There. Okay, let's look at our next problem. Got the integral of 1 over cosine squared dx. Now I could take the cosine squared up on top and becomes cosine to the negative 2 power, but I really don't have anything that helped me there. You know, I just got integral of cosine, so it has to match these exactly. Well, as I start looking through this, I see I have a secant squared here. And recall from trig, secant is equal to 1 over cosine. So 1 over cosine squared I can rewrite as secant squared. And from up above, the integral of secant squared is tangent. And again, we have to put the plus c on. So you may have to use some trig identities to help you rewrite them. Let's take a look at this one. Got the integral of sine x over 1 minus sine squared. Now if I go up to my formula up there, there's really nothing that looks like this. I mean, we have the integral of sine, integral of cosine, but we don't have anything that looks like this. But recall from trig that sine squared plus cosine squared is equal to 1. Now I can take this sine squared to the right side, and we get cosine squared is equal to 1 minus sine squared. So what that means is this bottom part that's 1 minus sine squared, I can rewrite that as cosine squared. Now I don't know if that's going anywhere yet, but we'll see. So that's cosine squared dx. Now I know I can split this up. I can rewrite this as sine over cosine squared is cosine times cosine dx, which I can rewrite this as sine over cosine times 1 over cosine. Because look at it going backwards. Sine times 1 is sine. Cosine times cosine is cosine squared. And also recall, and again, I don't know if this is really going anywhere yet, but tangent is equal to sine over cosine. And I think we already said this up above, but secant is equal to 1 over cosine. Which means I can now rewrite this. That's tangent. So we got tangent. And 1 over cosine is secant. So let's go see if we have a formula that has tangent and secant in it. Well, number 4, secant tangent. It's flipped around, but that doesn't make a difference. So the integral of that is secant. So this is now equal to secant. And we always throw our plus c on at the end. And that's our answer. Now this one is another formula we'll take a look at. Of course, sine I already wrote down. This one you don't see as often. Now here, see, we got 5 to the x power. Now 5 in formulas is usually represented, it's a constant, so it's represented as a. So our formula for this says a to the x power dx, where a can be any number, is equal to 1 over the natural log of a to the x plus c. So let's use that fact to help us solve this problem. So we got the integral of sine x plus 5 to the x dx. Well, sine up above, the integral of sine is negative cosine. So that one's pretty obvious. So it's negative cosine. Now here we got 5 to the x. Well, 5 is our a. So our formula says that we're going to rewrite that as 1 over natural log of 5, natural log of a, times a to the x power. So times 5 to the x power. And then we put our plus c on at the end. And that's our answer. Now here's another one that we're going to see a lot more in coming sections. If you have the integral of 1 over x dx, that's equal to the natural log of the absolute value of x plus c. Now you should have these in your book all summarized in one table. So I think every calculus book provides that. If not, you'll have to come up with your own sheet. So let's take a look at number 13. We've got the integral of 5 over x plus cosecant squared x dx. Now whether we have the 5 up on top or out in front, it's still just a number that just remains there. So I'll keep the 5 there. If I take the 5 away, that leaves us the integral of 1 over x, which we just said was this. So that's 5 natural log of the absolute value of x, cosecant squared. If I come up here, cosecant squared, the integral of that is negative cotangent. So this becomes a negative cotangent x, and then we put our plus c on at the end. And that's our answer. Let me go ahead and save this. And let's look at our next problem. We got g prime of x is equal to 5x squared. And they tell us g of 0 is equal to negative 2. And it says solve the differential equation. This right here is called an initial condition. And we'll see where we use that. But when they say solve the differential equation, they want us to go backwards. They want us to find g of x. Well, to find g of x, we take the integral of g prime, which will be the integral of 5x squared dx. Well, remember our formula. We got x to a power, we add 1 to our power. So 2 plus 1 gives us 3, and we divide by our new power, plus c. And it's g of x. Okay, now what they're giving us here with initial condition, the number that's inside of the parentheses, this 0, that's going to be our x. So they're telling us x is equal to 0. And for purposes of solving this problem, this negative 2 over here is going to be our g of x. So g of x is equal to negative 2. Now, to be precise, this is actually g of 0. And if I were to put 0 in for x, this would become g of 0. But I like to do this just so you can clearly see how everything matches up. Well, this tells us that we go ahead and put negative 2 in for g of x. For x, we said it was 0. So we'll put 0 in for x. Then plus c. By giving us this initial condition, they allow us to solve and find out what c is. Well, this one's really easy. 0 to the third is 0. 0 times 5 is 0. 0 divided by 3 is 0, so that drops away. So we get c is equal to negative 2. So this g of x right here now becomes g of x is equal to 5/3 x to the third, and we now know what c is, so I'll put that in, so minus 2. And that's our answer. And that's how we use the initial condition to help us find out what c is. Now let's take a look at this one. I think I have room. We got our second derivative is equal to cosine. And boy, I don't know. Might be kind of iffy. Let me start a new page. Sometimes these get kind of long. They don't necessarily get hard, they just get kind of long. So let me go ahead and save this. There we go. Time for my tablet to blow up. There we go. And this is 15. And again, our second derivative is equal to cosine. And our f prime of 0 is equal to 1. And f of 0 is equal to 4. Okay. Well, we start with our second derivative. To go back 1, to go to our first derivative, we're going to have to take the integral of our second derivative, which will be the integral of cosine x dx. Well, I don't have my sheet up anymore, but the integral of cosine is sine. And then we put our plus c. So this is f prime. Now our initial condition, we have two initial conditions. This one applies to the first derivative. The number that's inside of your parentheses, that's your x. So they're telling us x is equal to 0. And what's on this side is going to be your f prime of x. So f prime of x is equal to 1. Specifically, it's here f prime of 0. But for purposes of this notation here, it's f prime of x. So we'll put 1 in for f prime of x. We'll put 0 in for x plus c. Now sine of 0, if I look that up in my unit circle, that's equal to 0. So that's going to drop away. And we get c is equal to 1. Which means that our first derivative, f prime, now becomes sine x plus 1. We plug in the c we just found. Well, that's not what they're asking for. They're wanting their original function. So to go back one more, to find f of x, we're going to take the integral of f prime. Well, f prime is sine x plus 1 dx. Now, again, I don't have my sheet up, but the integral of sine was negative cosine. And 1 just becomes 1x, or just x. And we put our plus c on. So that's our f of x. Now we need to find our what our c is equal to. So we're going to go up and look at our initial condition. If we look at what's inside the parentheses here, that's going to be our x. So they're telling us x is equal to 0. And what's on this side will be our f of x. So f of x is equal to 4. So I'm going to come down here and plug those in. So we just said f of x is equal to 4. And negative cosine, and x was 0. Plus, and this is just 1x, or x. So we put 0 in for x, plus c. So again, we just plugged in what we identified there. Now we want to solve for c. Well, cosine of 0 is 1. So that gives us negative 1, and that 0 drops away, plus c. Take that negative 1 over, and we get c is equal to 5. So our f of x now becomes, we now know what c is. It's negative cosine x plus our c, which was 5. And that's our answer. Let me go ahead and save that. go. And I believe that was the last problem, so I'll go ahead and stop the recording.